String off, so I'm going to need the reference string back. Yes, please.
2,
2,
3,
I need Indian accent. Yeah.
1,
2,
5,
3, 1,
5,
5,
2,
2,
4,
4,
5,
5,
3,
3,
2,
2,
5,
5,
2.
2. Alright. Indian accent, please. Now, what are we going to do is, we are going to use a second chance algorithm. Awesome. Second chance. I think this was the first movie script that I ever wrote in my life. It was titled as Second Chance. Alright, let's start with the page trace. So I'm going to show the empty frames first. Page out. Page in. As I said earlier, we are going to maintain a reference bit for each page in the memory. So first 2 goes in, nobody goes out, right? Initially the reference bit is set to 0. So 2 goes in, nobody got out, there's a page fault. Next, we require 3 in the memory, there's a space in the frame. So 3 goes in, nobody goes out, there's a page fault. Reference bit of 0, 2 remains 0. Reference bit of 3 initially set to 0. Now we require 2 again, but 2 is already there in the memory. So nobody goes in, nobody goes out. We need another marker. There is no page fault because nobody goes in, nobody goes out. But the important thing to understand here is that because 2 was referenced again, and there was no page fault, reference bit of 2 is set to 1. Reference bit of 2 is set to 1, of 3 it remains 0. So whenever a certain page repeats itself, causing no page fault, its reference bit is set to 1. Now there's 1 we require, there's empty frame, so 2, 3, 1. Nobody, 1 goes in, nobody goes out, page fault. Reference bit of 2 remains, 1, 3 remains, 0, and as 1 is new, its reference bit is set to 0. Next we need 5, right? Now, 5 is not there in the memory. 5 is not there in the memory, right? 5 needs to come in, somebody needs to be replaced. We have 3 potential candidates, 2, 3 and 1. Whom do we replace here? See, good news is we are using the FIFO variant of the second chance algorithm. So usually we would apply the FIFO rule. Whoever has come first out of these 2, 3 and 1 will replace it with 5. So who has come first? Actually 2. I guess if you see, 2 has come the first. So ideally, if you are using FIFO, plain FIFO, you should replace 2. But because this is a second chance algorithm, we have to take one more factor into consideration. That factor is the reference bit value. Now here the actual victim is 2 according to FIFO. But because 2's reference bit is set to 1, it gets a second chance. Because its reference bit is set to 1, it gets a second chance. And in that case, the next victim falls in line. The next victim is the one who came just after 2, that is 3. FIFO applies without 2 now. FIFO applies only to 3 and 1, and in that case 3 is our victim for replacement. So we replace 3 with 5. So 5 comes in, 3 goes out, 2, 5, 1, and as 2 has got its second chance, its reference bit is reset to 0. So it becomes 0, 5, new one, so reference bit 0, 1's reference bit was already 0. So now we require 2, right? Now, fortunately 2 is already there in the memory. So nobody goes in, nobody goes out, no page fault. But there is one more thing to consider. Because 2 is coming back again, causing us or saving us a page fault, its reference bit, it will be rewarded with the value for reference bit as 1. So 2's reference bit becomes 1. 5, 1. Their reference bits remains unchanged. Next we have 4, right? Now 4 is not there in the memory, So 4 needs to come in the memory. That means somebody needs to go. Who will go? 2, 5 or 1? So this is a FIFO variant, right? So if you apply the FIFO rule, who is the oldest?
2.
2 again? But again 2 has got a lifeline. 2's reference bit is set to 1, so 2 is out of consideration. 5 and 1. Out of 5 and 1, who is the oldest?
1.
1 is the oldest.
Yeah.
So 1 is our victim. Replace 1 with 4. So 2, 5 and 4. As a result of the second chance, 2's reference bit is set to
0.
0. 4 is new candidate, so its reference bit is automatically 0. Now we require 5. Fortunately 5 is already there. So good news, for 5 is going to get rewarded. Oh, 5 is already there, nobody comes in, nobody goes out, no page fault. And 5 is going to get rewarded with
1.
1 reference bit value as 1. So 5 is safe from any elimination or any replacement. In the next few, you could say, advancements. So now, what do we require next?
3.
3?
Yeah.
3 is there in the memory? No. So we need it. 3 needs to come.
Yeah.
That means somebody needs to go.
Yeah.
Who will go out of 2, 5 and 4? If we apply the FIFO rule, because this is a FIFO variant of second chance algorithm, 2 needs to go.
Yeah.
Because 2 is the oldest. And this time, 2 doesn't have the power of 1. 2 doesn't have its reference bit set to 1. So 2, this time, you are not to be. So 2 goes out. So we just say 3, 5 and 4. And reference bit of 3 is new candidate, so 0. 5 remains unchanged, 1 and 4 becomes 0. There is of course a page fault. Now we require 2. So this time around we require 2. Somebody needs to go out.
Yeah.
If you apply the plain FIFO to 3, 5 and 4, who is the oldest in 3, 5 and 4?
No. 5.
In the 3, 5 and 4, 3 is the latest,
Yeah.
5 is the oldest. 5 has come first amongst 3, 5 and 4. But 5 cannot be the replacement. We cannot replace 5 because 5 has the power of reference bit set to 1. So because 5 is out of say race, now there are only 2 victims left, 3 or 4, out of which 4 is, you could say, first in ahead of 3. So 4 will go out, 2 will come in, 4 will go out. So 3, 5 and 2. Now 5 has used its second chance, so its reference bit gets reset to 0. 3 is 0, 2 is a new entry, so 0. Of course there is a page fault. Now next thing we need is 5 again. Very good. So there is no page replacement here, no page fault. 3, 5 is there, 2 is there. As a reward for saving us a page fault, 5's reference bit gets set to 1. 3's and 2's remains same. Now next thing we require is 2. Good news, 2 is already there in the memory. That means nobody goes in, nobody goes out, no page fault. But as a reward for saving us a page fault, 2's reference bit gets set to 1. Unfortunately, there is no time now to use their reward points, and we are done with the page faults. If you look at the number of page faults, 1, 2, 3, 4, 5, 6 and 7. 7 number of page faults, so you could say it is much better than lots of page replacement algorithms that we have studied today. So this is the second chance algorithm, and we studied the FIFO variant of the second chance algorithm.